Hello everyone and welcome to ABB Robot tutorials. In this tutorial we will learn how to use a Teach Pendant or a Flex Pendant to control the motion of the ABB Robot. For example, in this video tutorial you will learn how to move the robot in the axis or in the jog mode that is illustrated over here. So if I press this joystick left and right, the robot will move around this axis. For example, if I rotate the joystick, the robot will move like this. And besides this, you will also learn how to move the robot in other modes, in the so-called linear mode that's illustrated over here. In the linear mode, the robot moves along X, Y, and Z linear axes. And then you will learn how to move the robot in the so-called reorient mode, where basically the robot rotates around the tip of the end effector. Here, for illustration purposes and for simplicity, we will be using the RobotStudio to simulate the robot motion in a virtual environment. That is, we will be using a virtual twin of the robot and the virtual twin of the Teach Pendant or the Flex Pendant. However, everything explained in this video tutorial can be applied to a real ABB robot. This is mainly because your Teach Pendant looks like this. So what you can see over here is a virtual model of a Teach Pendant. And everything what I'm pressing over here and doing, you can do the same thing on your real Teach Pendant or Flex Pendant, and everything will be the same. Okay, let's start. My first goal is to create a virtual model or a digital twin of the robot such that I can demonstrate the motion modes. For that purpose, I opened RobotStudio, then I click here on New, then I clicked on Project, and over here I will not click on Include a Robot in Virtual Controller. I will simply click on Create, and later on I will create the robot in Virtual Controller. Okay, now the first step is to add the robot to our workspace. So I will click over here, I will click on RB120, I will click on OK, and here's the robot. The next step is to add the end effector or a tool to my robot. To do that, over here I will click on Import Library, and let's select under Training Objects, let's select this pen, for example. Okay, now the pen is located over here at the center of this coordinate system over here, and the next task is to attach our tool or the end effector to this coordinate system over here. That is to attach it to a robot. To do that, right click on the pen and attach to, and click over here to the robot, click on yes, and here it is. Here's how to attach the pen. And then let's rotate and let's see how this thing looks. To rotate, we need to press Control Shift hold, Control Shift, then press and hold the left mouse button and simply move the mouse left and right. To zoom, you need to use the middle mouse button. If you have a mouse with a roller, you will simply roll back or forward or backward the middle mouse button, and this is how you can zoom. Or you can simply press the middle mouse button and move it left or right. And then finally to pan, press and hold Shift and move the left mouse button. Okay, good. The next step is to add the virtual controller to our robot. So click over here, click from Layout, and let's click on Next, let's click on Next, and let's click on Finish. This will add the virtual controller to our robot, and over here you can see controller status. You can see currently it's red. This means that the virtual controller is still not active, and after some time this will become green. And after that we can continue. Now, in RobotStudio you can actually easily move the robot, and you can do that by simply clicking over here and selecting, for example, the axis or joint, and you can simply rotate by holding the left mouse button and by moving the mouse left or right. Okay, however, this is not how we move the robot in practice. To move the robot in practice, we need to use either the Rapid Programming Language or we need to use the Teach Pendant. So let's explain how to use the Teach Pendant, since this is what you will do in practice. To use the Teach Pendant, we need to do a few things. First of all, click over here on controller, and over here click on operating mode. Currently the operating mode is auto, and this is not what we want to do. We want to have a manual operating mode, and click on enable device. So again, click on manual and click on enable device, and this will bring the possibility to manually control the motion of the robot. Next, we explain how to bring up our FlexPendant, or better to say, how to create a digital twin or a virtual simulation of our FlexPendant. Well, that's very easy. You simply need to click over here on FlexPendant. And here it is. Okay, and this is exactly the model of the FlexPendant of your real-life robot. And you will have the same functions over here. And notice that this FlexPendant is a FlexPendant that comes together with this robot. Okay, so let's learn how to use this FlexPendant and how to move our robot. First of all, I will click here and then I will pan to move here the robot. Then I will close this since I will not need this option. Now, the issue over here with ABB RobotStudio is that this window of the FlexPendant is actually very large, right? And you can see robot over here, only part of the robot. However, we'll have to live with this constraint. Okay, so to move the robot, you need to click over here, and you have several options. For us, the most important option is this option jogging. So click on jogging. Okay, now let's see what's happening over here. First of all, let's go over this menu over here. This is a mechanical unit. This is not important. This is absolute accuracy. This is also not important. And you can see here the motion mode. This is the most important option for the time being. And over here we can select the motion mode. So let's click over here and let's see what do we have over here. Over here we actually have 3 motion modes, although you actually see 4 options. These 2 options are actually a single motion mode. And this type of motion mode is called the axis motion mode or the joint motion mode. So what happens over here, once this option is selected and pressed OK, I can move the joints of my robot. That is, I can move the joints 1, 2, and 3. 1, 2, and 3. Okay, and you can see here the instructions. These are the joystick directions for movement. So if I move down my joystick, let's do it, you'll see that robot should rotate around this joint over here. Okay, so I will select it and you can see it over here. Okay, now if I kind of move my joystick left or right, I will move the robot around this joint and you can see it over here. So if I press here or if I press here, the robot will rotate around the z-axis. Okay, how about 3? 3 means the rotation around this joint, right? So to do that, I need to rotate my joystick and you can see what happens. And the same thing applies to your robot. Then, if you, for example, move the joystick in this direction, you will have a combination of several modes, as you can see over here. Or over here, you can see also a combination of several modes of motion. Now, what is very important to observe is that over here you can read the angles of your joints. You can see the first, second, and third one. These are the angles measured by the absolute encoder that's installed over here near the motors. Okay, so over here we can only move the robot around the joints with the number 1, 2, and 3. How about the other joints? 4, 5, and 6. Well, we need to go back over here in the motion mode and we need to select axes 4 to 6. So select here and click on OK. And you can see 5, 4, and 6 are activated. So let's test them. If now I move left or right, I'm moving around this joint over here. And you can see that the angle is changing over here. Similarly, if I move up or right, I'm actually rotating around this joint, up or down. You see it over here. That's the joint number 5. And let's see the joint number 6. So if I rotate my joystick, you can see that I'm moving around 6th. And now I can have combinations if I press over here. So I can have motion that looks like this. And that's it. Next, we explain how to move the robot in the linear mode. To activate the linear mode, you need to click over here on the motion mode, and over here you need to select linear and press OK. Now, over here we need to explain several important things. First of all, we need to discover what we are actually moving in the linear mode and what is a linear mode. First of all, let's do a simple test of a linear mode. Now, over here you can see that joystick directions changed. Now if we move joystick down, we should move along the x-axis. Okay, now I will click over here to show you the coordinate system. Here it is. X should be in this direction, Y should be in this direction, and Z should be upwards. So let's test that. Okay, so if I press down, I should move along the x-axis. And let me move this up so you can see the motion over here, and you can see the x-axis. Okay, so it looks like if I press up and down, I am moving left and right. That is, I'm moving along the x-axis. Good. How about if I try to move along z-axis? I can rotate the joystick and I can see that actually I'm moving up or down. That is, I'm moving vertically in the z-axis. Now, how about the y-axis? Well, if I press the joystick left or right, I'm actually moving along y-axis. However, you might ask me the following question, but what am I measuring? So let's say I'm moving something along the x-axis, but am I actually moving the coordinate system located over here or this coordinate system? Notice that you have this coordinate system that's attached to the center of this plate over here, and you have another coordinate system that's attached over here, that is to the tip of your tool, or basically of the tip of the pen. Now, how can you figure out the coordinate systems? Well, if I click here, you'll see that actually this option will be activated. Now, let me bring this option so you can see where it is. So usually now, if you press on home over here, you are in this option, you are in controller. Now if you press home, if you expand controller, if you go here, and if you go here, if you expand this, now if I double click over here under the tool data, you can see that I activated this pen TCP. That is the pen tool center point. And tool 0 is actually this coordinate system. Okay, so if you cannot find coordinate systems, you can do them like this if you're, of course, in RobotStudio. However, if you're playing with a real robot, then you will have to do experiments, and I will show you how to do that. So over here, we have tool 0. Now, let's bring back the menu over here, and let's written what is written over here, tool 0. Okay, so this means that we are actually moving, or better to say measuring, in x, y, and z coordinates this point over here. That is the center of this coordinate system attached to this plate over here. To see it better, let's rotate it a little bit. So here it is. And let's move it a little bit like this. Okay, so let's bring up the Teach Pendant. And what you see over here, these x, y, and z are the x, y, and z coordinates of this center point over here with respect to what? Well, with respect to coordinate system. That is the base coordinates system. Okay. This is very important, and we can simply test this. So let's test this by moving, first of all, by moving this point all the way to z equal to 0 and to y equal to 0. Now let me now simply rotate this joint over here such that the robot, such that you can better see the motion. So let me do that. Okay, let me just do this a little bit. Okay, I'm like this. Now, let's see what will happen if we try to move z all the way to 0. And over here you can see the z value, so let's move it all the way down. Okay, z, z, z. And let's see what will happen. Okay, now z is equal to 0. And you can clearly see that the center reached almost 0. However, the center of this coordinate system is below our plane. And this means that we are actually tracking the center of this coordinate system, and these coordinates are actually the coordinates of this point. And this is how you can actually experimentally determine what you're actually tracking. Of course, over here you're going to crash the robot, and you shouldn't do this. However, you can always measure the offset or do something similar. Okay, so let's move y to 0 to really confirm that we are actually tracking this point. So to do that, we need to basically move left, 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 or right, and we are almost there. Actually, we are almost there. Let's do it like this, and that's it. Now we located the center over here of this coordinate system to y is equal to 0 and z equal to 0. Okay, and now let's go up, and you can see how nicely we can move everything. Let's move along the x-axis, and you can see that we are moving parallel to this coordinate system over here. Next, we need to explain what is Q1, Q2, Q3, and Q4. These values over here are actually the components of a quaternion. Quaternion is a mathematical object used to describe rotation of one coordinate system with respect to another coordinate system. That is, quaternions are used to describe orientations of two coordinate systems. Now, I will not go into mathematical details, and quaternions are not so difficult to understand. However, they are not straightforwardly related to the actual angles. So let's change the position format by clicking over here, and let's use the Euler angles and click OK. Now, over here we can see EZ, EY, and EX. These are actually the rotations of this coordinate system over here with respect to this coordinate system. And we can see that the rotation around z-axis, that is around this axis over here, is almost 90 degrees. Now, this explanation leads us to our third motion mode. That is, it leads us to the reorient motion mode. To activate this motion mode, we need to click on linear, and we need to click here on reorient. Okay, and let's see what's happening over here. Now we have again joystick directions, and now we have X, Y, and Z again. However, now X, Y, and Z are not linear motions along X, Y, and Z axes. They're actually rotations. So here it should be mentioned that the center of this point is actually always staying fixed, and this is very important. That is, the center of this point stays fixed. And now if I rotate my joystick over here, I will have rotation around z-axis. So let's see that. Okay, and you can see the rotation around the z-axis while this point over here stays fixed. Let's see the rotation around the z-axis again. Let me just bring it a little bit back. Okay, you can see over here. Now, how about the rotation around x-axis? So let's see that. To rotate around the x-axis, over here we can see that we need to move the joystick up or down. So let's see what's happening. Okay, you can see that we are rotating around the x-axis. And you can see over here that x-axis is staying fixed. How about the rotation around another axis, y-axis? So now this is y-axis, and the y-axis should stay fixed. So you can see it over here. We need to move left or right, and you can see that y-axis is actually staying fixed, and we are rotating. To summarize, when we activate the reorient motion mode, we are actually over here fixing this point and we are rotating around these axes of this coordinate system. X, Z, and Y. Okay, that's all for today.